Hello and welcome. If you're watching this video, I hope that you have taken the time to look at the lesson about factoring a sum or difference of cubes. So this time what I would like to do is take a look at a couple more sums or difference of squares, and I want to take a look at some somewhat more complicated examples. So there are only two examples that we're looking at, and the first one is example number 5. Factor a to the 6 b 12 minus 729 c to the power of 12. So what we want to do here is first inspect and see if we have the sum or the difference. It seems that we have the difference of two terms, and we're hoping to make these two terms look like cubic terms. And as you see in here, we have a6b to the 12. The way I like to do it is write the brackets, write the power of 3 outside, and then try to think what numbers or what terms do I have to place inside the brackets. So raised to the power of 3, that would still give me a to the 6b 12. So if we have a to the 6, that means that inside the brackets, we're going to need a to the power of 2. Remember, we are applying the power law here. So the power of the power when you multiply the exponents. And for b to the 12th, we have to write b to the power of 4 inside the brackets. The next term, again, same idea. We are going to write the brackets, write the power of 3 out. And as you see here, we have a coefficient and a variable. We have the number 729, which is actually 9 to the power of 3. And inside the brackets, I'm going to write the coefficient 9 because I know 9 to the power of 3 will give 729. And for C12, we'll write C to the power of 4. So here we go. So 4 times 3, 12. So now that I have rewritten the difference of cubes in proper form, where I can see what is being raised to the power of 3 in each term, I think that I'm ready to go ahead and start the factoring process. So here goes my binomial, and here will go my trinomial factor. Okay, so it's a difference of cubes, so minus between the terms in the binomial. The value of a is, that's kind of ironic to say because we have the variable a exactly here, but these are the terms that have been cubed in this case. And we're going to say that must write a squared b4 here, and then minus 9c to the power of 4 here. Now the next factor will be in trinomial form, so the first part here, this one, to the power of 2. So a squared b4 to the power of 2. And the last term, I think I need to make a little bit more room in here. So the last term is 9c to the power of 4 squared. In the middle, we're going to have the product of a squared b4 with 9c4, and it will be positive since we have the difference of cubes there. So we have 9a squared b4 c4. Not a lot of room here. Okay, and now we are going to polish this expression a little bit more. So we have a squared b4 minus 9c4, and the other factor will be, we are allowed to bring the exponent in. So we have a to the 4, b to the 8, plus 9a squared b4 c4. And the last term, remember, the power of 2 will apply to every part of the term inside the bracket. So 9 squared, which makes 81, and c to the 4 squared, which is c to the power of 8. And that would be the second factor. Now, one little trick or one thing you want to remember is the fact that the factor that is in trinomial form cannot be factorable. You can't factor it any further. So try not to torture yourself thinking, but I must find something in here because look at how much stuff I have. So it is not factorable. But we should always focus on the first factor, the one that is in binomial form. And the reason why is because sometimes you may find another difference of cubes or sum of cubes hiding here, but you must also look for sum or difference of squares as well. And it seems that since the powers are all even numbers in here, there is a chance of this being a difference of squares. So I'm going to write the first term. Here we go. I'm going to highlight this. A squared b4 as a term squared. So here we go. So if I want the power of 2 here, then inside the brackets, I need ab squared. And 9c4 can be written as a squared term, which is 3c squared. And that will be another way of writing the first factor. We haven't done anything in terms of factorization. We have just expressed it as the difference of squares. That's all. And the other factor, I know it's a little bit annoying, but you just have to keep on writing. You have to write complete steps. So write the solutions in complete steps. I've seen very often people like to work only on the part of the expression that they're working with or they're transforming. And then they write the equal sign here all the way. But that would be mathematically incorrect. So going back to our difference of squares, we're ready to factor it because we do see what we have hidden in here. So remember that difference of squares formula. Just to recall one more time, I'm going to write this on the side. I'm going to write it with X and Y, so we won't confuse it with those letters in here, A and B. So x squared minus y squared is x plus y, x minus y, okay? So that will turn into ab squared minus 3c squared multiplied by ab squared plus 3c squared. And then we have to write the last factor, a4b8 plus 9a squared b4c4 plus 81c8. Check one more time in case you have anything else you can factor in here, and I would say no. You don't have to check the sum of squares, if you have any. This, by the way, isn't because a and 3 won't allow it to be. But the sum of squares is never factorable. It's actually one of the questions that we try to give students, to trick you sometimes. But remember that, not to trick you, but just to create a memorable moment. But remember that if you can factor difference of squares, that doesn't mean that you can factor the sum of squares. This is not factorable. Okay, just in case that ever happens to you, since we're mentioning it. So this is it. This will be the final answer for this question. Okay, I'm gonna highlight it because it just looks neater. So we're gonna move on to the next example. By all means, try to factor this on your own. Why not? So I am going to get started here, and we have x to the 6 plus 1/8 y to the 24. So we have the sum. Both 6 and 24 are multiples of 3, so it can be sum of cubes. And number 8 is a perfect cube number. So I'm going to rewrite the expression as a term cube so that I can see what we are cubing here. So we have x to the 6. So if I put power 3 in here, that means x squared must be inside the brackets, and then plus. And then to power 3 here. So y to the 24 is y to the 8. And here we have 1/2. And now we're going to say we have this term cubed and this one here cubed. and start factoring. And we have x squared plus 1/2 y8 multiplied by, here we have the trinomial factor, x squared squared. Remember, when you have the sum, the minus will be over here. So minus 1/2 x squared y8. And the last term, which is half of y to the power of 8 squared. So again, let's write this down a little bit nicer. X squared plus 1/2 of y to the power 8. And x4 minus half x squared y8 plus 1/4 y to the 16. And this is the final answer. If you're thinking of factoring this, again, it's not factorable. The powers are multiples of 2, but this is not a perfect square, and this is a plus, not a minus. So this is not factorable, and we know this is not factorable as well. So we're done here. And actually, we are done with sum and difference of cubes. And I hope that you enjoyed this kind of straightforward grill and drill kind of questions and concepts. And I hope everything made sense. I'll see you again.